Okay, I'm going to show you where those binomial coefficients come in multiplying out binomials, and kind of show you where the binomial theorem comes from without doing a formal proof. So first of all, if you remember, this is a formula you're supposed to have memorized. If you have a binomial and you square it, then you get a squared plus 2ab plus b squared. That's if the binomial was a plus b. Remember the 2ab in the middle. So the coefficient of the a squared is 1, the coefficient of the ab is 2, and the coefficient of the b squared is 1. So written in terms of binomial coefficients, it looks like that. 2 choose 0 is 1. How many ways if you have two objects, how many ways can you choose none of them? Exactly one way. You just don't choose any of them, right? That's 2 choose 0. If you think of it in terms of factorials, 2 factorial over 0 factorial times 2 factorial. 0 factorial is 1. 2 factorial over 2 factorial is 1 because any number over itself is 1. 2 choose 1. If you have two objects, how many ways can you choose 1? Well, you choose the first one or you choose the second one. There's 2 ways. So 2 choose 1 is 2. Any number choose 1 is the same as the number. 5 choose 1 is 5. Because you're choosing 1 out of the 5. There's 5 ways to do it, right? 10 choose 1 is 10, etc. Anything choose 0 is 1. 10 choose none. You have 10 objects. You don't choose any of them. 1 way to do it, right? So anyway, that's where those binomial coefficients come in there. Now, if I cube this, you don't want to do this all by hand. See, this is where our binomial theorem will come in. If we wanted to raise this a plus b to the 21st power, we don't want to do it by multiplying a plus b times itself 21 times, like one at a time. It'll take us forever, and we'll probably get it wrong. So notice how symmetric the coefficients are. The coefficient of a cubed is 1, coefficient of a squared b is 3, coefficient of 3ab squared is 3, and coefficient of b cubed is 1. So the coefficients go 1, 3, 3, 1. Now why the 3? The 3 is just 3 choose 1 is 3. Just like 2 choose 1 is 2. So this is actually 3 choose 0, a cubed, 3 choose 1, a squared b, 3 choose 2, ab squared, 3 choose 3, b cubed. Seems like a lot of formula, I know, but you'll get the pattern eventually. When we do examples, you'll see how it goes. It's not that hard. Notice what happens with these numbers, though. First of all, the number on top is the same as the power that I'm raising the thing to, cubed. See, so the number on top of all of these is a 3, right? The denominators start at 0 and go up 0, 1, 2, 3. Now notice how many factors of b there are in each term. There's no factors of b, 0. There's 1 factor of b, 1. There's 2 factors of b, 2. There's 3 factors of b, 3. See, this number on the bottom here is the number of factors of b in there. Notice also, each one of these terms has 3 factors other than the binomial coefficient. It has, right, AAA, AAB, ABB, and BBB. 3. Why 3? Because it's cubed. Where was that? Right there. It's cubed. Right? Second power. Right? 2, 2, 2. No b's. 1 b, 2 b's. Right? 1, 2 factors. 1, 2 factors. 1, 2 factors that aren't the binomial coefficient. 2. So 4, you'd expect the same pattern. And this is the thing that's good about this, is it follows the same pattern. And then you can compute these. These are easy to compute. This is 1, this is 1. Because taking 3 is the same as leaving 3. This is 3, this is 3. It's pretty simple. But once you get above cubes, you start getting more interesting binomial coefficients. So you see how that works? So just looking at this is a 4th power. So we have 4 factors of A, 3 factors of A, 1 factor of B. So 4 factors total. 2 of each, 4 total. 1 and 3, 4 total. Right? And notice what happens to the powers of A. A to the 4th, starting with this one, cubed, squared, that's A to the 1 power, and then there's no factors of A. You have to get down to none. The B's start with 0, 1, 2, 3, 4. So see the A's decrease in power from the 4 down to 0, and the B's increase in power from 0 up to 4. And then all you need to know is where did that, this one's always a 1 in front, this one's always a 1 in front. This is always the same as this, and the second from the last is also the same. The question is, where did the 6 come from? And that's from 4, choose 2. 2 factors of B. 4 choose 2 happens to be 6. You can try it if you want. Get 4 objects. Try to see how many ways you can pick 2 of them. You'll see you get 6 of them. 6 different ways. So that's that. And it keeps going like that for 5, 6, 7, 8, 9, as far up as you want to go. So that gives us the binomial theorem. It just follows this pattern, okay? So this is just figuring out what it would be. Then mathematicians would go in and prove that it's correct for all integers. But we don't need to do that. But I wanted to show you the pattern, kind of where it came from. So for any positive integer, n, if we take this binomial, a plus b to the nth power, right, we'll get n choose 0, a to the n, plus n choose 1, a n minus 1. So the exponent on the a decreases by 1. That's all that's saying. And you get a b plus ... Plus somewhere in the middle, you get n choose k of a to the n minus k. Notice those exponents. These exponents always add up to n. That's what I was saying before, right? Exponent 2 and 2 adds up to 4, which is the power, right, that you're raising it to, the 4th power. So these two add up to, that's just a term in the middle. The last one will be n choose n. That's just a middle one, just to, fill in the middle there. We'll use that for something. Okay? So the denominators of your binomial coefficients go from 0 up to n. The numerator here, or not the denominator, the bottom number in the binomial coefficients start from 0, go up to nth power, right? The top number in these factorials is always n, right? 0 tells you the number of factors of b, and the number of factors, total number of factors, always have to add up to n. So if that's n, then there's no b, there's one b, so you have one less factor of a, right? If you have k b's, then you have n minus ka factors of a, and here you have n b's, so you can't have any k's because you're using up all n factors. Okay, so you need to know that formula. Now you don't need to be able to write this exactly the way it's written here or anything. You have to be able to use it given specific a, specific b, specific power n. Just practice these, do a few of them, And you'll see it's not too bad. That term right there is the k plus 1th term. Sometimes they'll ask you to write out the kth term of something. And the kth term, you have to remember this is going to be k minus 1. Because if you write out k there, that's the k plus 1 because there's the 0 ones, right? So it should be n choose, the k plus 1 term is n choose k. The kth term will be n choose k minus 1. It's the one right before this term. All right, so I'll show you that when we get to it.